At this first example, we have, I'm going to do one graph at a time. Y is less than negative x plus 2. So I'm going to do a little mock-up up above before the final graph. So on this first graph that we've got here, notice it is already in slope-intercept form. What do I mean by that? Well, I already have the y-intercept to graph this line. I would start at the point 2. I'm going to draw this on both of my graphs because no matter what, I'm going to have the graph of the line. And then the next part would be to use the slope. Notice that the slope is kind of hidden. It's a negative 1, which means what's on the bottom is also another hidden 1. So if we use our slope as a rise over a run, the negative 1 as the rise would mean that you're going down 1. Your run, though, is positive, so that would be to the right 1. So we'd go down 1 and right 1. Down 1 and right 1. I'm going to do that on both of my graphs. So once I've done that, on both of my graphs, I start at 2 and I go down 1 and over 1 on both graphs, is I can draw my line. Be careful, what kind of line is it? Well, because it's less than, not less than or equal to, it's going to be dotted. So I can draw my line through my points. I'm going to draw it again on both graphs. It's going to be a dotted line. Okay. Now, what I'm not going to do on both graphs is now I'm going to do the shading. Remember, to do the shading, I need to test a point. Well, I'm only going to do the shading on my mock-up, and I'm going to test the same point I always test, which is 0, 0. So I'm going to test 0, 0 on my inequality, which was y is less than negative x plus 2. So that means I'm plugging in, let's see, 0 for y and 0 for x. So what that gives me now is 0 is less than, and on the right-hand side, I've got 0 plus 2, which is just 2. So the question is 0 less than 2? And the answer is yes, it is. So what does that mean about 0, 0? The point does work. So for this first graph, we will shade the side that 0, 0 is on because it worked. I'll shade that side. Again, I'm only doing the shading on my mock-up because the final shading on my final graph should only be an overlap. Okay. Now I have to do my second graph, which is y is greater than or equal to negative 1. Well, notice that this equation is special because it only has a y in it. Remember, if equations of lines only have a y or only an x, we have a special case. And in this case, a y is the y. The y is telling us y, which is the h means horizontal line. Remember, horizontal lines go left and right. And where is it going to hit the y-axis at? Negative 1. So it means if I hit the y-axis at negative 1, I'm going to have a horizontal line. What kind of horizontal line? Be careful. It's going to be, because of the equal to here, it's going to be a solid line. So that means down here at negative 1 on both of my graphs, I'm going to have a solid horizontal line. Okay. The question is which side of that horizontal line to actually shade. I'm going to test the same point, 0, 0. So let's see. I've got y is greater than or equal to negative 1, and I'm testing same thing I've tested before, 0, 0. Be careful. On this equation, I can only plug in a y of 0. There's no x to plug in. So I'll plug in my y of 0. And I get 0 is greater than or equal to -1. Is that true? 0 is greater than or equal to -1. It's bigger. So what does that mean? It means for my horizontal line, 0, 0 worked. So that means for the horizontal line, I'm going to shade that side of it, which here's my horizontal line. I'm going to shade the side that 0, 0 is on, which means this upper side of the horizontal line. Okay. That means I have my sketched out graph done along with the shading, but this is kind of my preliminary graph. It's not done. I still need to shade in my final answer. My final answer should be only the part where the two graphs are overlapping, which happens to be, you can see it pretty well now, this triangle here. So that's the only part that I should be shading in my final answer. So my final answer is just this graph right here. So if you were doing your final graph in MyMathLab, you would draw your two lines as we did here, and we'd only put the paint bucket over on this side to fill this side in. So here we are with our final graph that should be painted in with this triangle, where we're only shading in the overlap here, and this triangle. And again, like I said, this is our final graph. If you're doing these by hand and want a good way to kind of check your work and show your work, is if you get, like, let's say a yellow and a blue highlighter, they'll a lot of times bleed together and make green, so that you have a good way to kind of visually indicate you have an overlap. Or if you get a pink and a blue highlighter, when they overlap, you'll get a purple color. Those are good ways so you can quickly identify overlaps so that you'll know which part of your graph is your final answer. Just an idea.